When you start a new software project, you're super excited about the potential of the project and you want to get moving as soon as possible, which is great. Often when that project matures and you get more customers and you get more users, things need to change because you start getting feedback from your customers. That's one thing. The other thing that happens is technologies change. Database systems might change. You might have to add a new user interface. And you want to be able to do these things without having to rewrite all of the logic. How do you do this? So I've been running software companies for the past 30 years. And at some point I was, dismayed or surprised to see how difficult it becomes to change things if the logic is all over the place. If you have business logic in your database layer, in your business logic layer, sometimes in your user interface layer, little rules that you've got everywhere, then at some point nobody knows really what all these rules are. So this is what happens. As you're moving really quickly in the beginning, somebody asks for a feature and you just go, one of the developers goes and just adds it somewhere. And if there's no real clear rule where that should be, that could be in the front end, it should be in some form of business logic layer, it could be in the database, it could be a stored procedure or a view or something that contains that logic. If this keeps on happening over a few years for a very successful project, you are stuck. Because you won't have the time to go back and understand what exactly are all these little rules that was implemented. Some of them are micro rules that affect big things, like the way interest is calculated or the way finances are created. That's the problem that layers solve. Layered architecture, specifically what we're going to talk about now is clean architecture. This is the problem that it solves, and I'm going to talk about this right now really quickly. So in episode 3, the mission here that we need to do is we need to refactor our code into these different layers. And we need to implement a rule, that's the dependency rule in clean architecture, that means that all dependencies point inwards. Let's talk about this. So you need to go to episode to clone this code. This is the code you'll use. Look at read quest 3. This is the instruction for quest 3. Read through all of this. Read the blog there by Robert C. Martin. The blog's a bit dated, some of the terminology is a bit old, so I'm going to talk through some of these concepts right now. Then we need to refactor to the delivery layer. You'll see the different layers over here. Just go back. So the application layer, the domain layer, and the infrastructure layer. At this point, we're going to implement these 4 layers. And you could, sometimes the layers are called something different. Some people call it presentation layer instead of delivery layer. Some have more layers. This will be a great overview of how this works. So let's keep it simple like this. I love these wordings, specifically delivery layer, because that's where your application is delivered to the world. It's also responsible for delivering incoming messages to the application itself. Then we'll enforce the dependency rule. This is going to be a big one, and there's a interesting code that you need to write to get this done. That's a more of a visual overview of the dependencies. And then what I also did is I showed you what the project structure should look like once you're done. So this is what you're seeing right here. Success criteria code is organized into layers, which is folders. These are folders described above. Inner layers do not reference names from the outer layers. That is the dependency rule. Any broken dependencies are fixed after the move. And then just add a docs folder as well. That's just the typical standard. Okay, so I'm going to talk you through this. What is this all about? Keep the most important logic separate. I talked earlier about business logic. We want to keep that into the domain and application layer. Those are the 2 layers that need to know about business logic. The other layers have infrastructure as well as the delivery mechanisms like the fastapi or command line interface. We'll talk about that now. Problem, when everything is slightly connected, changes get harder. That's what I talked about earlier. Bugs spread farther, so things are connected all over the place, and one thing affects another thing, and when one thing breaks, everything breaks. That's the bug spread farther concept. Testing becomes painful because now you need to test everything. You need to test your database, your front end, your business logic. All of this are intertwined. In a clean architecture, you can test only your domain and application. You can test only your domain logic, and then you can also test your application use cases and services. And then you can go and test infrastructure as well, but those are the hearts of it, and you can keep those tests separate, which ends up surprisingly making the tests sometimes hundreds of times faster to do. You can run hundreds of tests within less than a second, versus if you need to involve databases, it becomes substantially slower. So we can do these tests in memory, and we're going to talk about that when we look at the repository pattern and the unit of work. So testing becomes painful, new features becomes riskier because now you're changing stuff and it can break stuff in unexpected ways. Mental models become more complex. This is the thing that I really have found. If you have a clean architecture, you have this folder structure, and you have the concept of dependencies only pointing inwards, then you have a clear understanding of how everything works, which is really important. Computers don't struggle with this, but software developers do. And I feel especially now in the world of AI, where code can get generated in its millions of lines in minutes, it's really important to keep the structure well organized, keep the dependencies well understood, have a mental model which you can participate on instead of just being an observer and trying to figure out what AI is doing. That will be a recipe for a disaster. So I feel it's even more important now to have this. Business rules end up locked to specific tools. That's part of the... You for example, have business logic in fastapi. It's a disaster, because then if you have a command line interface, you need to repeat it there. If you have events coming in, you need to repeat it, and you end up repeating yourself all the time. The simple solution: put core business rules in the center, put changing technology on the outside, fastapi as an example, or the command line interface, or databases, or messaging infrastructure, or authenticating systems. Keep the center stable, even if the outside changes. Do not couple parts together unnecessarily. This is a visual overview of the layers: delivery on the outside, dependencies pointing inwards, infrastructure, application, domain is the heart of the system. The application layer is like an API that works with the domain. So they go hand in hand. I just put these on here so you can see when we're talking about the outer layer: command line interfaces, web APIs, user interfaces, incoming events, GraphQL API scripts. Those are the entry points. That's where you deliver your application logic to. Also, anything coming in from a script as an example, or an event, that gets delivered to the inner parts of your application from the delivery layer. Again, that's why I like the terminology delivery layer. Infrastructure layer is where you put any infrastructure that your application relies on. For example, database, file storage, messaging, external APIs. You might have a Twilio integration or a payment solution integration. That will be in the infrastructure layer. Logging, authentication. Then you have the application layer. That's where you define your data transfer objects. We're going to talk about that in the next episode. These could be dictionaries or classes, objects that get sent from the delivery layer into the application layer. Application services have use cases, and those interact with and use the domain layer and also interact with infrastructure. Then you have the heart of the system, the pure rules. This is the domain layer. So back in the day, 20 years ago, before that, code was just all in a bunch of files. Similar to episode 2. When we wrapped up episode 2, you had all of your code files in one big folder there. That's the way it used to be. But at least we separated them into some logical files. steps back and it would be one big file of code. So then people introduced a 3-layered architecture, or sometimes 4-layered architecture. That would be you're keeping your logic separate. You have your presentation layer, and then you have the business logic layer, and then you have the data access layer. Notice that the bottom layer here is the database, and everything depends on the database, which is the exact opposite of what I just showed you. So I want to compare clean architecture now to 3-layered architecture, or 3-tiered architecture. Clean architecture, your primary goal is decoupling logic from technology. Now in 3-tiered architecture, that's not the goal because everything is coupled to the database. So you're basically separating the tiers into logical responsibilities or functional responsibilities. The center of the architecture in clean architecture is the domain. That's the heart of the business rules. And this was, what was his name? So Robert C. Martin expanded on this in his book, Clean Architecture, but the original book was Domain-Driven Design. Domain-Driven Design clarified this idea that if you keep your domain simple, it becomes easy to understand what the application does. Everything else becomes a technical concern. But if you want to understand what the business logic is, you'll look at your domain, and then you'll go one step further. You'll look at your application layer. And combining those two, you will have all of your business logic right there, and anything else will sit on the outside. And it's not messing around with your mental model of understanding what this should do. So whereas with a 3-tiered architecture, you have the database at the center, the schema at the center. Flexibility, clean architecture is highly flexible. You can swap a SQL database, no SQL. People always talk about swapping. Now, it doesn't happen often that you want to swap the database. So I don't like that as an example. One of the biggest benefits that you do get is all these other little technologies, like fastapi can be changed. In a clean architecture, you would be able to take a fastapi and change that to the next big thing. Only a few years ago, it was Flask. And you would be able to change Flask to fastapi without changing any other layer, without touching any other layer. You'll only touch the delivery layer. You'll add a new command line interface, or you will adopt, instead of a certain messaging system, start using gRPC without touching any other layer. That's where the flexibility really comes in. That's the one big advantage. The other thing is the mental model, the simplicity to understand what's going on in all of these layers. In a 3-tiered architecture, the flexibility is moderate. Changing the database often requires rewriting parts of the business logic. Again, I don't want to focus on the database here. I want to show you something though. If you look at this, the arrows there are not talking about dependencies. Dependencies in a 3-tiered architecture often are all over the place. It's not such a big thing to say that, oh, nothing needs to depend on something else. And that often becomes very messy. Whereas with clean architecture, you have an unbreakable rule, the dependency rule, where everything points inwards. So I'm just bringing this up again. And then for a more clear view of the dependency rule, look at this graph. It's often misunderstood that you have to go through all the layers. It's not the case. The delivery layer can talk directly to any other layer. The only thing is, delivery layer knows about all layers because it's the outside. But the moment you move one layer into the infrastructure layer, it should not know anything about the delivery layer. So you should not even mention fastapi there. This does become challenging from a programming point of view, and you use this concept of programming against interfaces instead of implementations, which we're going to look at in this episode as well, because it affects us with the repository. If you look at episode 2's code, you'll see that the repository is mentioned and imported into the application layer, which is wrong. Big challenge for you is going to be, how do you solve that? How do you How do you still keep a structure in the application layer without mentioning JSON? Application layer should not know about JSON. You should be able to swap JSON to, let's say, Postgres without touching the application layer, or JSON to Firebase without touching you should even be able to support multiples. And often we see this with testing. Once you start testing the application, you won't test it with JSON, you'll test it with an in-memory memory store to get that sub-second speed for all of your tests. If you run 100 tests, 200, 300 tests, you want that to execute in seconds, not minutes. And that's going to be part of what we'll see how to do in this episode. So the layers, those are the layers I talked about. Domain. I've mentioned the domain, application layer, data transfer objects. We use Pydantic for that. We've already touched on that in episode 1 and 2. Now, the data transfer objects transfer data from the delivery layer to the application layer or other layers in a standard way. Typically, application layer where we unpack it and we start going through the use cases. Infrastructure. The main rule, inner part should not depend on outer parts. We talked about that. The core should not know about the infrastructure or delivery details. Dependencies should point inwards. Why this helps? Anything we do has to have a reason. Easier to test the core logic. We talked about that. Tests become super fast. They also become isolated. You can test the domain on its own, then application use cases on its own without even touching technology. The advantages are simpler tests as well as super fast tests. Easier to change tools later, so you can swap out. We talked about that. Easier to understand the system. Mental model becomes super simple, or at least much more simpler than what it would have been in a big ball of mud where everything talks to everything. Less risk when making updates. This is a big one. Systems need to remain flexible, ready for change. And if everything's depending on everything else, change becomes risky and is due to that high risk is often not done, which means you get stuck in the mud. I used to travel through with 4x4 in Africa. I've got amazing photos of where we got stuck in the mud. And interestingly enough, they call this system that everything depends on everything a big ball of mud. I would just say it just reminded me back in the day where a vehicle would get stuck in the mud. And sometimes I've stories where we were stuck for 2 days in the mud in a Land Cruiser. So that's what you don't want. You want to stay nimble. You want to have a Lamborghini or a whatever, Corvette, or name your car, Porsche, and you want to be able to always move your application forward, adapt to business needs without getting stuck. Biggest benefit. Key takeaways: protect business logic from changing technology. Keep the important rules at the center. Build so the core stays clean and stable. I would say mental model needs to be added here. Keep the mental model simple. So somebody asked one of the great developers, I can't really remember who he was, but he's quoted in this book, Clean Architecture. What is a clean architecture? And he said it's code that can fit into your head. And what he means is it's code that's easy to understand. And obviously that doesn't have anything to do with the computer, the machine, the PC, the Mac. It doesn't need to understand the code. It runs the code. This is for us to understand. It's for us to stay involved, stay in control, and easily be able to change things and keep things stable. And that's sort of the story. Go ahead, implement Quest 1 episode 3. I will see you in the code through of this quest. By the way, I'm going to use Codex to code through it. I've already done it actually. It was mind-blowing. I'm excited for you to see how I use Codex to implement this quest, and I've got some interesting takeaways on that. See you in the next episode. Cheers.